ओके क्लास 10 ल आजको क्लास सुरु गरौँ है। आजको क्लासमा हामी devices, okay, that are made on the basis of Pascal's law को वर्किङ स्ट्रक्चर र युजको बारेमा पढ्छौँ। र सुरुमा हामीले गएको क्लासमा ओके जुन डिभाइसको बारेमा डिस्कस गर्दै थियौ नि, that is hydraulic garage lift, also known as hydraulic garage jack को बारेमा त्यसको स्ट्रक्चर वर्किङ र युज पढ्छौँ। त्यसपछि बाँकी दुईटा डिभाइसको बारेमा डिस्कस गर्नेछौँ। ओके सो लेट्स बिगिन। here we go, sorry. Okay, yes, right, let's start the class. Please all of you listen to me properly. Then the picture shown is hydraulic jack, or also known as hydraulic lift. And this machine or device is used, okay, to lift vehicles, okay, like car, buses, even trucks, okay, small vehicles like motorcycles, so as to repair or even for the purpose of cleaning in garage or somewhere in service station. Okay, so hydraulic jack is used to lift, okay, heavy vehicles, so in garage or service station. So talking about the structure of this machine, okay, this device or machine has three metallic cylinders, so of different size. That means they are different in diameter. You can see this cylinder, this, and these three metallic cylinders. And among these three cylinders, okay, these two cylinders, that second and third, are fitted with piston. So you can see over here. So this part is piston. Okay, you can see that small piston that is fitted on a small cylinder. So where we apply the force, and then big piston, obviously, so in big cylinder. So further, okay, these three cylinders are connected. So by a connective tube, this horizontal connective tube, so which has, okay, two valves on it. Okay, this connective tube has two valves on it. So here in the figure you can see they are named as valve A and valve B. Okay, connective tube has two valves, the name A and B. Okay, these valves open in one direction, open in same directions, but they open or they work at different time. Means when the valve A is open, at the time the valve B will be closed. If the valve B is open, then the valve A will be closed. Okay. So in addition, dear students, okay, these two cylinders, that is where we store the fluid or liquid water called reservoir, and the big cylinder. So where that vehicle or the load is kept, which has to be overcome, are connected with another tube. You can see, okay, that's just below that figure here, connect this tube, okay, below the connective tube here, so which had stopper on it. Okay, stopper means that can be closed or open for the purpose of letting that water get pass from one part to another part. So structurally, so what can we say in short? Okay, garage lift has three metallic cylinders connected by a connective tube, and these two cylinders, okay, are fitted with piston, that is small piston and big piston. So further, all the cylinders are connected by a connective tube, so which has valves, okay, A and B. And then this reservoir and big cylinder is further connected with a tube, so which has tap on it, or let's say stopper on it. Okay, and whole system is filled with liquid, that is water, because this device is designed, okay, so that it works on the basis of Pascal's law. That means transmission of, okay, equal pressure by the liquid, so in all direction. This is the structure of hydraulic jack. Now let's go to, okay, learn or discuss about the working of hydraulic jack, also known as hydraulic lift. So how does it work? So when the apparatus or the device is set, okay, for the purpose of lifting, so heavy vehicles in garage or service station, and for the first, force is applied on a small cylinder, or you can say small piston. So you can see that small piston is, okay, that is connected with the lever. So when the lever is moved, that means that the force is exerted on a small piston, okay, that makes the small piston moves inward. Okay, जब हामी यो लिभरमा फोर्स एप्लाई गर्छौँ, यो फोर्स एप्लाई गरिन्छ यसमा, अनि त्यसको फोर्सले यो पिस्टन के हुन्छ, भित्रतिर मुभ हुन्छ, and by which that pressure is created on the small piston, right? That the force applied on a small piston creates the pressure, and that pressure transmits. So due to which that valve A gets closed. Okay, that the valve A is the first valve A gets closed, it closes, and then valve B opens, so that the liquid can flow or the pressure can transmit, okay, towards the big cylinder. So as the lever is moved, that moves the piston inwards, creating the pressure. So by which the, okay, valve, okay, A gets closed and valve B opens, and the transmission of pressure so occurs from small piston or small cylinder towards the, okay, big cylinder. Understood? That means the small pressure or the pressure exerted on the small piston is transmitted to the big piston. And what happens here at the effect, okay, at the pressure reaches the big piston, that the force gets magnified, and so that that force is able to lift a heavy vehicle, okay, up, and so that we can repair its parts, or even we can wash or clean like that. Means that heavy load or heavy vehicle is lifted, so by the, or the inductions of the large force on the large piston. अब यो बिग पिस्टनमा लार्ज फोर्स त्यहाँ प्रोड्युस भयो, ओके, यहाँबाट गएको फोर्स यहाँ म्याग्निफायो भन्ने कुरा चाहिँ, ओके, म एउटा हाइड्रोलिक मसिन इज अ फोर्स मल्टिप्लायर भन्ने टपिक छ, त्यसमा हामी न्युमेरिकली नै हेर्छौँ है। र सिम्पली तिमीले के बुझ्नु पर्यो भने क्लास चाहिँ यहाँनिर चाहिँ, सो हाइड्रोलिक ज्याक obviously works on Pascal's law. Then how does it, okay, work, or what is the working mechanism of hydraulic jack? That force is multiplied, okay, or large force is produced on a big piston. So when the small force is exerted on a small piston, okay, small piston मा चाहिँ हामीले एप्लाई गरेको फोर्स स्मलै हुन्छ, तर जब लार्ज पिस्टनमा त्यो फोर्स पुग्छ नि, अनि फोर्स के हुन्छ, बढ्छ, इन्क्रिज हुन्छ। यो किन पोसिबल भयो भने, बिकज बोथ द सिलिन्डर्स पोजेस, ओके, इक्वल प्रेसर। स्मल पिस्टन भएको प्रेसर P1 र बिग पिस्टनमा चाहिँ जुन ट्रान्सफर भएको प्रेसर P2 त्यो के हुन्छ, इक्वल हुन्छ। अनि प्रेसर इक्वल भएको कारणले गर्दाखेरि यसमा भएको जुन स्मल फोर्स लार्ज एरियामा पुग्दा के हुन्छ, लार्ज हुन्छ, त्यसरी इन्क्रिज हुन्छ। इन दिस वे hydraulic jack works so that it can lift vehicles, okay, up. Got it? Now so let's go to another device, okay, second number, machine that is also constructed or manufactured that obeying the Pascal's law, and it is hydraulic press. So dear students, you can see the picture, okay, on your screen. So it is the real hydraulic press that is used, okay, in factory, and this device is used to, okay, compress the substance. It is used to, you know, crush, CRUSS, crush, okay, that is break the objects into pieces, and it is also used for, you know, extracting the whale from whale sheets. And you can see, this is the platform, this is the platform, this is the platform. Here you can see this one, so where we can keep the objects, and this part is moved. So when this part is moved, okay, towards this part, and the objects will be in between them, and the pressure, or let's say the force exerted by it, compresses the substance, and even the metal sheet can be changed into desired shape because it exerts large force. This works on Pascal's law. Okay, this is hydraulic press. Let's read structure, working, and use okay, of hydraulic press. Next slide. So you can see the pictures, so with some explanation of structure and uses. You can see the use of hydraulic press. It is used for compressing, okay, cotton bales, and then extracting oil from oil seeds, even punching holes in metals. So you can make holes even in metals, okay, by the use of hydraulic press, and giving even specific shape to metal sets. That means even the hard objects can be changed into desired shape by the use of hydraulic press. So if you, okay, try to know about the structure of this device, okay, called hydraulic press, so you can see there it consists of two cylinders, only two cylinders. Okay, so here one cylinder is named X, okay, another is Y, and you can see yourself that cylinder X is, okay, is smaller than the cylinder Y. Where what we have to understand is there. So while we design or manufacture any hydraulic machines, okay, that work on the basis of Pascal's law, so in those machines the cylinders must be vary in size. They must be different in their diameters. So here in hydraulic press also you can see that the two cylinders it has, so between which that one is smaller and another is bigger. So in this, okay, figure you can see the cylinder X is smaller and the Y is bigger. And we apply the force. That means we create pressure. So always on a small cylinder. Okay. And so that the pressure will be transmitted towards the big cylinder and the large force will be exerted. Okay, produced on the large cylinder or large piston. So this device called hydraulic press consists of two cylinders X and Y, okay, in which X is smaller, okay, than Y. And further you can see there both the cylinders are fitted with piston, and those pistons are watertight. Watertight means, okay, that is from this device the water cannot be escaped out. यो जुन भित्र डिभाइसमा फिल गरिएको लिक्विड छ अथवा वाटर छ, यो वाटर चाहिँ बाहिर डिभाइस बाहिर, ओके, निस्किन पाउँदैन. यो ननिस्किने गरेर राखेको भएर दिस पिस्टन्स आर वाटर टाइट and then even frictionless so that they can be moved easily. Okay. And here you can see further that is the cross sectional area, okay, of that small piston is A1 and the cross sectional area of that big piston is A2. So that the force applied on small piston is F1, and then force exerted on big piston will be F2. So both the cylinders, okay, definitely connected by this tube. And further if you sit there above the big piston, you can see the platform. So where we can land or keep the objects, so which have to be compressed or which have to be crushed, okay, by the help of hydraulic press. So above the big piston you can see the platform, and just above that you can see one, the rigid ceiling is very strong. Rigid means strong. So which is not, okay, breakable, or which can be broken by the force. So in between this means in between the platform above the big piston and the rigid cylinder, that is the objects are are kept there. So it has cylinder X and cylinder Y, where both are fitted with pistons P1 and P2 respectively, and the whole system is filled with water, or you can say liquid, because it works on the basis of Pascal's law. There is the transmission of liquid pressure equally in all directions, and then the load, okay, or the objects or substances which have to be pressed or compressed or let's say changed itself, they are placed on the side of big cylinder, and further there is a rigid cylinder, so which can help to press, okay, the substance in between the piston and the, okay, ceiling. Okay, this is about the structure of hydraulic press. Let's go to the working mechanism of this device, hydraulic press. Okay, the same working that we can say. So what we said, okay, for the hydraulic jack, that small force is applied. That means less effort is applied, okay, on the small cylinder, and that the small applied force, okay, when it gets transmitted to the big piston, okay, it gets multiplied, it gets magnified. Means by applying small effort on small cylinder produces large force on large piston. Again, and so that while we apply there, the force applied here produces pressure, okay, on the piston P1 or small piston. It transmits to the big piston, that is P2, and that makes that piston move, okay, upward, and which also helps to move the object towards the ceiling. And when the object remains in between the ceiling and the piston, or let's say platform, and it will be compressed, okay, and then they can be crossed, they can be, broken, okay, they can be, changed into shape like that. Okay. And it happens, or it occurs because of equal, okay, distributions of liquid pressure. So pressure at piston 1 and piston 2 is equal, okay, and because of equal pressure in both pistons, the force becomes variable, okay, force becomes different here, and the force on small piston is less, whereas the force on big piston is more. So force increases on the load side. This is working of a hydraulic press. Okay, now without any delay, so if you go to next device, that is also manufactured on the basis of Pascal's law. This device machine is also works on Pascal's law. This is called hydraulic, okay, brake system, and this is used in vehicles so as to stop the vehicles, okay, and this means this system is used to bring, okay, moving vehicle into rest. So this consists like this part, brake, and it also has two cylinders. Okay, that there is one cylinder where the effort is applied, and another cylinder where the force will be multiplied. And the two cylinders are master cylinder and wheel cylinder. And let me show another picture of the same system, means hydraulic brake. So in this picture, you can see, okay, the hydraulic system is connected in all four wheels of vehicle. So you can see the connections of the tube, okay, where the pressure gets transmitted, okay, to the wheels, and so that all the wheels get stopped, okay, by applying the force on them. You can see four, okay, wheels over here, the 1, 2, okay, 3, 4, and this is the brake. So where the driver applies the brake, okay, or let's say force, driver apply the force also on it, and the pressure transmitted toward the all wheels, okay, in this part. You can see it in this part, okay, and then the bus or the vehicles will be stopped. They can be brought into rest like that. So further, what is the structure of hydraulic brake, okay, and then working of hydraulic brake system? So we'll discuss in another slide. Here, why the class 10? ल हेर अब फिगर हेर त तिमीको स्क्रिनमा, okay, appear भयो होला. This is a third machine or third instrument, okay, that works on Pascal's law. This is hydraulic brake. Okay, it is used in vehicles, okay, for the purpose of stopping the moving vehicles. So when the vehicles have to be brought into rest, okay, while they are in motion, and this instrument is used, okay, to stop even very heavy vehicles. You can see over here, two cylinders it has, and in this system also both the cylinders are different in diameter. Okay, they are different size. So one cylinder here you can see, this is the first cylinder. So it is also called master cylinder. You can see master cylinder. So where the effort, okay, is applied, and the cylinder you can see here, okay, this one, and this is master cylinder. Okay, this cylinder, this one is master cylinder, and this cylinder, so which is connected with the wheel or rim of tire, okay, is called slave cylinder. SLAV is slave. This one is master. So where the effort, okay, is applied, and this cylinder that is connected with the tire, so where the force get multiplied. This is called slave cylinder. SLAV, slave cylinder. And another major part of the system is obviously, so from where we apply the force, that is brake pedal. Okay, this is brake pedal. So driver apply the force on the brake pedal. The applied force, okay, now it gets exerts on the master cylinder, and that creates pressure, and that pressure transmits, okay, towards this tube, and finally reaches to the slip cylinder. Slip cylinder. So the pressure created on master cylinder so moves towards or the transmits towards the slip cylinder, and the cylinders are of different size. Means here we apply the less force, and the here, okay, in slip cylinder the force gets magnified. And okay, both the cylinder master and slave, both the cylinders, they are also fitted with piston. So if you observe, okay, the figure, you can see the black in color, this part, this is piston. Okay, this part is piston here, and here you can see at either side, okay, of the same cylinder, that is black in color, this one. Okay, this part here you can see this is piston. So this cylinder called slave cylinder, okay, is also fitted with the piston, and the master cylinder is also fitted with uh, piston as well. Mhm. And the whole system is filled with fluid, because that also means this brake also works on Pascal's law. That means transmission of liquid pressure. Right? Now let's talk about the working, okay, of hydraulic brake. So how does a hydraulic brake work? अब हाइड्रोलिक ब्रेकले भेहिकल्समा कसरी काम गर्छ, ओके, हाइड्रोलिक ब्रेक युज गरेर भेहिकल्सहरूलाई कसरी स्टप गर्न सकिन्छ, कसरी रेस्ट गर्न सकिन्छ, द सेम वर्किङ मेकानिजम है, जुन वर्किङ हामीले हाइड्रोलिक लिफ्ट र हाइड्रोलिक प्रेसमा हामीले डिस्कस गऱ्यौँ, द सेम वर्किङ मेकानिजम. Okay, so when that hydraulic brake, okay, hydraulic brake is pressed, okay, जब ड्राइभरले, ओके, आफ्नो फोर्स, यो जब हाइड्रोलिक जुन यो पेडल छ, ब्रेक छ होइन, यो पेडल, त्यसमा चाहिँ फोर्स एप्लाई गर्छ, अनि त्यसले के गर्छ त भने यो भित्रको पिस्टनलाई मुभ गर्छ. ओके, सो एप्लाइङ द फोर्स अन ब्रेक पेडल, ओके, मुभ्स द पिस्टन, एन्ड द पिस्टन मुभ्स इनवर्ड्स, यो भित्रतिर जान्छ. कुनको पिस्टन भन्दाखेरि यो cylinder. So applying the foot pedal, the piston inwards in master cylinder. अनि जब यो पिस्टन मुभ हुन्छ त्यहाँनिर फोर्स एप्लाई भयो, फोर्स एप्लाई भएका गर्दाखेरि यो मास्टर सिलिन्डरमा अब के क्रिएट हुने भयो त, कन्स्टेन्ट प्रेसर क्रिएट हुने भयो. यो मास्टर सिलिन्डरमा जुन लिक्विड फ्युल छ, त्यो लिक्विडमा के हुने भयो, प्रेसर क्रिएट हुने भयो. यहाँनिर क्रिएट भएको प्रेसर अब के हुन्छ, ट्रान्समिट हुने भयो, ओके, सर्ने भयो, मुभ हुने भयो, जाने भयो. फाइनली कहाँ जान्छ त भन्दाखेरि यो स्लेभ सिलिन्डरमा, ओके, जुन सिलिन्डर छ हाम्रो यो विलमा कनेक्ट भएको, यो सिलिन्डरमा त्यो प्रेसर जाने भयो. अनि यो गएको जुन छ प्रेसरले गर्दाखेरि यहाँनिर भएको पिस्टनलाई गर्छ, मुभ गर्छ. यो जुन पिस्टन मुभ छ यो स्लेभ सिलिन्डरमा क्लास, ओके, यसमा चाहिँ, ओके, लास्ट फोर्स क्रिएट भएर मुभ हुन्छ. त्यसले गर्दाखेरि, ओके, स्लेभ सिलिन्डरसँग फिटेड भएको जुन पिस्टन छ यो चाहिँ आउटवर्ड मुभ हुन्छ, यता बाहिर जान्छ. है, यहाँनिर जुन मास्टर सिलिन्डरको पिस्टन चाहिँ इनवर्ड मुभ थियो, भित्र मुभ थियो, त्यसले गर्दाखेरि यहाँ प्रेसर क्रिएट भयो, प्रेसर ट्रान्समिट हुने गइसकेपछि, ओके, त्यो प्रेसरले अथवा यहाँनिर चाहिँ जुन म्याग्निफाई भएको फोर्सले चाहिँ यो स्लेभ सिलिन्डरसँग कनेक्ट भएको पिस्टनलाई गर्छ, बाहिरतिर धकाल्छ. अनि यो पिस्टनको मुभले गर्दाखेरि, ओके, योसँग कनेक्ट भएको जुन छ नि यो प्याड, यस्तो जुन हामीले यहाँनिर कब यसरी देख्छौँ, यो प्याडलाई मुभ गर्छ. अनि यो प्याड मुभ गरेपछि योसँग टाँसेर बसेको, योसँग अट्याच भएर बसेको जुन ब्रेक ड्रम छ नि है, त्यसलाई मुभ गर्छ. फाइनली के हुन्छ, रिमसँग कनेक्ट भएपछि रिमलाई के हुन्छ, स्टप गर्छ. अब यहाँनिर के हुन्छ, ओके, यो ड्राइभरले एप्लाई गरेको फोर्स चाहिँ स्मल एमाउन्टमा हुन्छ, ओके, लेस फोर्स भयो चाहिँ लेस एमाउन्ट भयो. तर जब यो इक्वल प्रेसर ट्रान्समिट हुँदै गएपछि यहाँको पिस्टन, यहाँको जुन छ यसको सिलिन्डर त बिग साइज छ, ओके, यसको क्रस सेक्सन एरिया डायमिटर त बढी छ, जसले गर्दा यहाँनिर प्रोड्युस भएको एक्जर्ट भएको चाहिँ फोर्स के हुन्छ, लार्ज हुन्छ. अनि यो लार्ज फोर्स प्रोड्युस भएको जुन छ है फोर्सले चाहिँ यो व्हीललाई के गर्छ त, स्टप गर्छ. सो इन दिस वे, so when small force is, okay, applied, okay, on a small cylinder or on a small piston, large force is, okay, exerted or created on the large cylinder, okay, which is enough, okay, to, okay, move the load, or for this case to stop the vehicle. So that हामीले के कन्क्लुजन गर्न सक्छौँ भने है, that the principle of hydraulic machine is Okay, that the big force can be produced on a big distance. So even by applying a small force on a small piston. So अब अहिलेसम्म हामीले पास्कल्स लको बेसिसमा ओके बनाइएका अथवा काम गर्ने जुन तीनटा डिभाइस थियो हाइड्रोलिक लिफ्ट हाइड्रोलिक प्रेस र हाइड्रोलिक ब्रेकको बारेमा त्यसको स्ट्रक्चर वर्किङ र युजको बारेमा डिस्कस गऱ्यौँ भने अब अर्को टपिक छ क्लास 10 हाइड्रोलिक मसिन अफ फोर्स मल्टिप्लायर भेसल अब यो टपिक अन्तर्गत चाहिँ हामीले न्युमेरिकल्ली ओके म्याथमेटिकल्ली है यो लार्ज एरियामा चाहिँ लार्ज फोर्स कसरी प्रड्युस भयो त भन्ने कुरा हामी जस्टिफाई गर्छौँ ओके प्रुभ गरेर हेर्छौँ र यो टपिक हाइड्रोलिक मसिन एज अ फोर्स मल्टिप्लायर भेसल ओके भनेर चाहिँ क्वेसनमा एक्जाममा फ्रिक्वेन्टली सोधिरहेको क्वेसन हो प्रुभ द्याट अर सो द्याट हाइड्रोलिक मसिन इज अ फोर्स मल्टिप्लायर है र यदि तिमीसँग कपी छ अहिले पेन छ भने ओके बिस्तारै नोट गर्दै जान सक्छौ है आफ्नो कपीमा नोट गर्दै जान सक्छौ लेख्दै जान सक्छौ बुझ्दै पनि जाऊ अब यस्तै क्वेसन आयो हाइड्रोलिक मसिन एज फोर्स मल्टिप्लायर ओके जस्टिफाई गर त्यसलाई प्रुभ गर त्यसलाई देखाऊ न्युमेरिकली भन्यो भने फर्स्ट स्टेप चाहिँ क्लास 10 हामीले के गर्नुपर्छ फिगर बनाउनुपर्छ ओके एउटा स्याम्पल अफ एउटा हाइड्रोलिक मसिन छ जसमा चाहिँ दुईटा सिलिन्डर देखाएको छ हैन अब अहिलेसम्म हामीले तीनटा डिभाइसको बारेमा पढ्दाखेरि र इभन यो हाइड्रोलिक मसिन एज अ फोर्स मल्टिप्लायर भेसलको डिस्कस गरिरहँदाखेरि हामीले एउटा कमन कुरा के पायौँ भने डिभाइसेसहरूमा जुन डिभाइस चाहिँ पास्कल्स लको बेसमा काम गर्छ त्यसमा चाहिँ के हुँदो रहेछ सिलिन्डर हुने रहेछ ओके एटलिस्ट दुईटा त्यसमा चाहिँ के त भने एउटा सानो र अर्को ठुलो ओके द मसिन कन्सिस्ट अफ टु सिलिन्डर्स ओके विच आर डिफरेन्ट इन डायोमिटर दैट मीन्स दे भ्यारी इन देयर क्रस सेक्सनल एरिया एउटा सिलिन्डरको एरिया सानो भयो अर्को ठुलो भयो अब यदि यो मसिनको हैन जुन सिलिन्डर छ यो दुईटै सिलिन्डरको एरिया तिमीले सेम राख्ने हो भने इक्वल राख्ने भने के हुन्छ भने त्यसमा फोर्स चेन्ज हुँदैन फोर्स पनि सेम बस्दिन्छ हामीले जति फोर्स एप्लाई गरेका छौँ त्यति नै फोर्स त्यहाँबाट निस्किन्छ एज अ मसिनको रूपमा त्यहाँनिर युज गर्न सकिँदैन है तर प्रेसर इक्वल हुन्छ अब यसको एरिया जति नै फरक परे पनि ठुलो सानो जे पनि प्रेसर चाहिँ इक्वली ट्रान्सफर हुन्छ अनि त्यही प्रेसर इक्वल हुने गरेको त एरिया चेन्ज हुँदा के हुन्छ फोर्स चेन्ज हुन्छ किनभने प्रेसर भनेको त फोर्स अपन एरिया हो है फोर्स अपन एरिया हो अनि यदि तिमीले प्रेसर भन्ने क्वान्टिटीलाई कन्स्ट्यान्ट राख्यो भने त अनि एरिया चेन्ज हुँदा त फोर्स चेन्ज हुन्छ नि त अनि त्यसमा के हुन्छ अब त्यहाँनिर ओके डाइरेक्टली फोर्स हुन्छ एरिया बढ्दाखेरि फोर्स बढ्छ र एरिया घटाउँदाखेरि के हुन्छ फोर्स घट्छ अब फर्स्ट स्टेपमा फिगर बनाइसकेपछि ओके त्यहाँ कन्सिडर गर्दैछौँ क्लास 10 है हेरेर assume that the hydraulic machine okay that has two cylinders of cross sectional area A1 गर्दैछौँ एजुम गर्दैछौँ हैन अनि बिग सिलिन्डर जुन छ त्यसको एरिया चाहिँ A2 भनेर हामीले चाहिँ कन्सिडर गर्दैछौँ है सो A1 and A2 are the cross sectional area of small and big cylinder respectively है अनि यसमा पनि के भयो त ओके यो स्मल सिलिन्डर बिग सिलिन्डर बोथमा के भयो त फिटेड विथ पिस्टन हामी अलिकति डार्क ब्लू कलरमा यहाँनिर देख्न सक्छौँ एउटा पार्ट ओके एउटा स्ट्रक्चर दे आर द पिस्टन्स एन्ड अभियसली स्मल सिलिन्डरमा फिट हुने पिस्टन स्मलै भयो र बिग सिलिन्डरमा फिट भएको पिस्टन बिग नै भयो है त सो दिस इज स्मल पिस्टन एन्ड दिस इज लार्ज पिस्टन ओके अब यो पिस्टन हामीले अहिले P1 P2 मान्यौँ भने ओके अब जुन हामीले एप्लाई गर्छौँ नि फोर्स ओके यो चाहिँ के भयो त स्मलमा F1 र बिगमा के त F2 बुझ्दैछौ है सो A1 and A2 be the cross section area of small and big cylinder respectively okay and the effort applied on small cylinder okay is F1 whereas F2 be the force okay exerted on big cylinder and we know that is A2 is greater than A1 the figure shows and when we the machine or when we design or manufacture the machine so we always have to okay that fit or connect the cylinders okay which are of different diameters यसमा चाहिँ A2 बिग सिलिन्डरको एरिया भएर A2 के हुने भयो A1 भन्दा ठुलो नै हुने भयो है त। अब A1 मा एप्लाई गरेको फोर्स F1 र A2 सिलिन्डर एप्लाई गरेको फोर्स F2 छ भने ओके डिस्टेन्स। अब यो स्मल सिलिन्डरमा के प्रोड्युस भएको प्रेसर कति हुनु भयो त भन्दा P1 मान्नु अहिले ओके। देन लेट्स एज्युम P1 be the pressure, right? P1 be the pressure so produced on small cylinder, and P2 okay be the pressure that transmitted on big cylinder. र स्मल तिर हामीले के गर्यौं एरिया A1 फोर्स F1 र प्रेसर पनि के त P1 गर्यौं है। स्मल सिलिन्डरलाई A1 गर्यौं अनि बिग सिलिन्डरमा के भयो त एरिया A2 राइट अनि फोर्स F2 and pressure also P2 है। अनि यति कन्सिडर गरिसकेपछि चाहिँ नाउ लेट्स युज Pascal's law। अब Pascal's law चाहिँ युज गरौँ so that we can prove that machine okay is a force multiplier numerically अथवा mathematically हामीले गर्न सक्छ प्रुभ गर्न सक्छौँ ल। So after drawing the figure of hydraulic machine, then writing the considerations okay that giving the meaning of different symbols. A1 for cross-section area of small cylinder, A2 for cross-section area of big cylinder. So where F1 is the effort applied on small piston and F2 is the force okay exerted on big piston, means P1 is the pressure on small piston and P2 is the pressure on the big piston. And according to Pascal's law, okay, so we have been reading that pressure transmitted is okay always equal in all points, that means in all direction. र हामीले अहिले एज्युम गरेको प्रेसर P1 र P2 छ भने यो दुईटै प्रेसर के हुने भयो इक्वल हुने भयो। सो प्रेसर अन द स्मल पिस्टन is equal to pressure on the big piston, and P1 so denotes pressure on small piston and P2 denotes pressure on the big piston. So है Pascal's law भनेको के हो त भने ओके लिक्विड प्रेसर सबै ठाउँमा बराबर हुन्छ। अहिलेसम्म अहिले चाहिँ हामीसँग दुईटा मात्र प्रेसर एज्युम गरेका छौँ भने P1 र P2 त्यो दुईटै प्रेसर के हुने भयो त इक्वल हुने भयो। सो बाई द ल okay given by Blaise Pascal, so called Pascal's law, so pressure on small piston is equal to pressure on big piston. So P1 is equal to P2 okay यही नै हो मेन okay main part P1 equal to P2 नै हो। And further that using the formula of pressure okay then we have what so F1 upon A1 okay equal F2 upon A2। अब यो जुन स्टेप छ भर्खरै हामीले डिस्कस गरेको क्लास 10 F1 upon A1 equal F2 upon A2 भन्ने जुन यो पार्ट छ नि हो यो चाहिँ फर्मुला ओके बाइ Pascal's law। यो फर्मुला युज गरेर हामी आउँदो दिनहरुमा न्यूमेरिकल प्रब्लम गर्छौं। सो व्हाट इज द फर्मुला ओके अफ Pascal's law भने हामीले भन्दिने के हो त okay F1 upon A1 equal F2 upon A2 okay। If we know the area okay of cylinders and the force applied, then we can easily calculate the force exerted on the large piston है। हामीलाई A1 A2 थाहा छ F1 थाहा छ भने हामीले F2 हामीले सजिलै सिधै निकाल्न सक्छौं। कति फोर्स एप्लाई भएको थियो भने अब कति फोर्स चाहिँ प्रोड्युस भयो भने कुरा हामी निकाल्न सक्छौं। So this okay step is the formula given by Pascal's law। यसलाई चाहिँ राम्रोसित याद गर यो चाहिँ। अब यहाँनिर हेर थर्ड स्टेपमा भने ओके अब एरेन्ज गर्यौं हामीले रिअरेन्ज गर्यौं जस्तै F1 तिर हामीले के गर्यौं A2 ल्यायौं हैन यो पार्टमा यो स्टेपमा अनि इक्वल के गर्यौं F2 तिर के गर्यौं A1 गर्यौं। अब हामीलाई पहिले थाहा छ है A2 is B1 A2 क्रस सेक्सन एरिया जुन A2 छ यसको भ्यालु त A1 भन्दा ठूलो छ लार्ज छ भने अब यो A2 को भ्यालु राख्ने हामीसँग A1 चाहिँ के अरे A1 छ यता अनि F1 चाहिँ थाहा छ भने अब जुन प्रोड्युस भएको अथवा जुन हामी निकाल्न खोज्दै छ नि यो F2 यो अब्भियसली के हुन्छ त लार्ज हुन्छ हैन भने जस्तै यहाँ हेर जस्तै यो F1 A1 एज इट इज राखौं F2 लाई चाहिँ यहाँ सिंगल राखेर A2 यो त सेट गर्यौं भने ओके A2 त क्रस मल्टिप्लाई भएर माथि न्यूमरेटरमा जान्छ अनि F1 A1 भनेको त्यो प्रेसर नै हो यो र यो इक्वलै छ अनि ए भ्यालुमा त्यो A2 जुन आफै लार्ज छ नि अनि त्यो लार्ज नम्बरले अनि न्यूमेरिकल के देखाइदिन्छ A2 ओके A1 भन्दा यदि ग्रेटर छ भने F2 पनि के हुनु पर्छ डिस्टेन्स ग्रेटर देन F1 ओके। So when the area change, then making the area of piston more, and obviously the force on that, okay, that piston or say area also increases. तिमीले कुनै सिलिन्डरको एरिया तिमीले बढायो, ओके, त्यसलाई ठुलो बनायो भने अब त्यसमा चाहिँ प्रोड्युस हुने फोर्स के हुँदो रहेछ त, बढ्दै जान्छ। तर न्युमेरिकल्ली यसरी देखिन्छ, हुन चाहिँ प्रेसर इक्वल नै हो, र फर्दर हामीले फोर्स र एरियाको टर्ममा जब त्यसलाई कन्भर्ट गर्छौँ नि, कन्भर्ट गरेपछि यो A2 भन्ने जुन छ यसको भ्यालु नै ठुलो भएपछि अनि F2 को भ्यालु कति निस्किन्छ भन्दा ठुलै निस्किन्छ। यसरी चाहिँ तिम्रो हाइड्रोलिक मसिनमा जब दुईटा सिलिन्डर छ, दुईटा सिलिन्डरको एरिया त्यसको डायमिटर फरक छ भने, ओके, अनि जुनको एरिया डायमिटर ठुलो छ त्यतातिर के हुँदो रहेछ त, बढी फोर्स प्रोड्युस हुँदो रहेछ भन्ने कुरा देखायो। यो किन सम्भव भयो त भने बिकज अफ इक्वल, ओके, ट्रान्समिसन अफ लिक्विड प्रेसर। यो दुईटा यो प्रेसर जुन छ स्मल पिस्टन र बिग पिस्टनमा दुईटै ठाउँको प्रेसर बराबर भएको कारणले गर्दाखेरि एरिया चेन्ज हुँदाखेरि फोर्स के भयो त, चेन्ज। क्लियर छ है? ओके, अब जाउँ अर्को टपिकमा। अब बिस्तारै हामी आज क्लास सक्दैछौँ। समअप गरौँ डियर स्टुडेन्ट्स। ओके, तिमीहरूले ध्यान दिएर सुनिरहेछौ, इभन क्लासमै छौ भन्ने मैले आशा गरिरहेको छु। Okay, and the sum of the principle of hydro machine, okay, is obviously that liquid is non-compressible matter, so due to which the liquid can be used in machine, okay, which works on Pascal's law. That means that it can transmit the equal pressure in every point. And second, obviously the law, that is Pascal's law, so which always tells that the transmission of liquid pressures, okay, equally and perpendicularly in all directions when the liquid is kept in an enclosed vessel. अनि अब लास्टमा चाहिँ भर्खर हामीले डिस्कस गरेको त हेर्दै, जस्तै हामीले F1/A1 = F2/A2, ओके, यो गरे पनि अब त्यसलाई एडियन्स गरे भने वी क्यान फाइन्ड A2/A1 = F2/F1। दैट मिन्स द रेशियो अफ एरिया, ओके, इज इक्वल टु द रेशियो अफ द that is area of another cylinder. So ratio of that area of big cylinder to that of small cylinder, that is A2/A1 = F2/F1. That means F1/A1 = F2/A2, है। यो भनेको त यो F1/A1 = F2/A2 के हुन्छ, यो दुईटै बराबर हुन्छ। यो भनेको त प्रेसर नै हो, ओके, P1 = के त P2 नै हो। गट इट? सो फाइनल्ली, ओके, यहाँ जान सक्छौँ। ल, स्क्रिनमा तिमीले देख्यौ होला द लास्ट कन्क्लुजन। सो आफ्टर रिडिङ, ओके, स्ट्रक्चर, वर्किङ, युज अफ हाइड्रोलिक मसिन्स लाइक hydraulic lift, hydraulic press, and hydraulic brake.